Okay, so the problem is two particles are fixed to the x-axis. Particle 1 of charge negative 2.53 times 10 to the negative 7th coulombs is at the origin, and particle 2 of charge positive 2.53 times 10 to the negative 7th coulombs is at x2 equals 20.9 centimeters. Midway between the particles, what is the magnitude of the net electric field? So to find the net electric field, we need to take the sum of the first electric field and the second electric field. To do this, we can find the electric fields of 1 by multiplying Coulomb's constant by the first charge over distance squared and adding that to the same thing but for the second charge. And we can simplify this to Coulomb's constant over distance squared times the sum of the absolute values of the first charge and the second charge. And we know what K is. K is going to be Coulomb's constant, which is 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. Now we need to find r squared. And to find r squared, all we need to do, since x1 is at the origin, is divide 20.9 centimeters by 2. And we'll get 10.45 centimeters, which is going to be roughly equivalent to 0.105 meters. And now all we have to do is plug in these values into the equation and cancel out our units, and we will get 8.99 times 10 to the 9th Newton meters squared per Coulomb squared, all over 0.105 meters. Multiply that by the absolute value of charge 1, which is negative 2.53 times 10 to the negative 7th coulombs, and positive 2.53 times 10 to the negative 7th coulombs. And I've already done this calculation, but to show you that the units cancel out, we can, these are going to add, and 1 degree of coulombs is going to be left over, so it's going to cancel out for one of these. This is going to square, this is going to be meter squared, I don't know why I put it there, but these will cancel out. And the net electric field, I've already done this calculation, and it's going to be 4.12 times 10 to the 5th newtons per coulomb.